Hola amigos, welcome back. So in this video, this is all about finding the proof, proving that the sum of an arithmetic series is given by this particular expression. And this is from the C1 Edexcel Maths syllabus and based on the sequences and series. Okay, so what are our terms here? First things first, we have our first term given by A. A is the first term, D is the common difference, and N is obviously the number of terms in this case. Now, how do we prove this in particular? I think first things first, we should consider a series, okay? Consider a typical series. If you're going to have a series, let's think of this numerically. So suppose we start with 1, and then our common difference was 2, so we have 3. And of course, we're going to keep adding 2 until we get some infinite number of terms up to, say, the final term would be 1 plus n minus 1 times 2, okay? This would be the nth term, okay? Now, as you notice in this case, if we're going to write this algebraically, what do we have here? So the sum of this term here is simply going to be the first term A plus the second term, which is A plus its common difference. The next term again is the original A plus the second common difference, and so on. And as you see, we reach the original expression, A plus n minus 1 times D. Now this would be the sum, okay? So this is we're almost pretty much there. Now, to actually prove this in particular, we need to somehow, in a way, factorize terms quickly and somehow get some sort of common difference. What I would do here is I would reverse this myself. So I would make the same sum equation, but this time start backwards. Why? Well, you'll see why in a second. So what do we have here? If we did this backwards, we're going to start with the last term, A plus n minus 1d plus A plus, before that is n minus 2d, plus plus the very first term, or let's do this one first, plus A plus D plus A. Okay, so this will be the first term, and the last term, the second last term, all the way back to the first term. Now, with these two equations, notice something here. What happens if we add these terms together? Let's just have a quick look. What happens? So suppose we add the terms across, what we're going to get? Okay, let's do the first term add the last term, the second term add the second last term, and the final term add the last term. What would we get? First, of course, we need to add up Sn too. So we're going to get Sn plus Sn is going to be 2Sn. A plus n minus 1d, we're just adding A, so it'll be 2A plus n minus 1d plus A plus D plus this term. What do we have? A plus A is 2A. Let me just put a nice bracket here. And D plus this term. So think about this. You have n minus 2 lots of D's and you add in an extra D. So we're going to have n minus 1 lots of D's plus ... And again, the last term, A plus A is 2A. And since we have nothing else, it'll be n minus 1D. And voila, notice something. We actually have the same term across. In fact, we have the same terms for n number of terms. So actually, we have this n times. So factorizing this, we have this n lots of times. So we have n lots of 2A plus n minus 1 D. And of course, all this equals 2Sn. And lastly, we're doing some nice little algebra here. We could just divide by 2. So this means Sn equals n over 2 times our original expression. And guys, that's it. This is the proof. It's actually a very basic proof. So the general idea is to notice the fact that when you're adding terms, you're going to get the same term in every term. So you can just factorize it n lots of times. And that's it. Hope this proof helps. And if you need any other proofs, let me know in the comments below. Thank you guys. Bye bye now.